remember, since it's been so long, remember that I is the imaginary unit, and it is the square root of -1. Okay, so anytime that you have I squared, you can replace it with -1. Good. So we are encountering things that you usually could not solve for x, but using I, we may be able to. Okay. Here we have x squared equals 16. So to solve for x, we just want to do the inverse of what is happening to x, right? So x is being squared. To do the opposite of that, we take the square root of x, right? Because the square root is the opposite of squaring something. So we'll do the same to the other side. Remember that if you're taking a square root while solving something, you have to put a plus and a minus, because it is true that, right, the square root of 25 could be 5. Well, the square root of 25 is 5. It's not a good reason. The reason is that 5 squared is 25, and -5 squared is 25. So there are always two different numbers that can give you 16. Or sorry, two different numbers squared that can give you 16. You can say 4 squared is 16, but you can also say that -4 squared is 16. So we include the positive answer to that, which is like the most popular one, the one that your calculator gives you. But we also want to include the less popular, but also true answer to it. Good. That is the only reason we do the plus and the minus. So the square root of x squared, the square root symbol cancels out that 2. So we have x is greater than, or sorry, my last class, it was greater than or equal to, and then less than or equal to. But that's just positive or negative. The square root of 16 we know is 4, right? So x is either -4 or 4. Any questions? All right. The next one is x squared equals -25. We're going to do the exact same process, where to get rid of the square, we take the square root, and we're going to take the square root here, okay? Just like before, we add a plus or a minus in the front, because there are two ways to get to 25 by squaring, right? It could be -5 or it could be a +5. But this isn't 25, this is -25. If I put that into my calculator, it's not going to give me, make it so you can actually see that happening. Here's regular 25. It's just 5, right? But -25 is an error. Okay? So you cannot take the square root of -25 and get a real answer or a real number. So what we do is we factor the square root of -25 to make it -1 times 25, right? Because then I can take the square root of 25 if it's positive, and I know that the square root of -1, I can call I. I can just put an I behind all of this and make the negative disappear. So if I was rewriting it again, it would be the square root of -1 times the square root of 25, and then I'm taking the positive and negative value of both of those. Good. Then I translate that to the positive and negative. The square root of -1 is I, and the square root of 25 is 5, right? I'm going to flip those around. Any questions? So here the x squared was immediately canceled out by the square root symbol. Here we put a square root symbol over everything, as well as a plus and a minus. We factored negative 25 into negative 1 and positive 25, the square root of positive 25 is 5, and the square root of negative 1 is I, so it's plus or minus 5i. So x is negative 5i, or x is 5i. Our last one is x squared minus 2x plus 5. You can, we're just solving for x, right? So we can try to factor it. It would be x times x. Is there anything that multiplies to equal a positive 5 and adds to equal a negative 2? There's not, right? So we can instead do the quadratic formula. So this is just another opportunity to practice the quadratic formula, which is x is negative b plus or minus the square root of b squared minus 4a times c over 2a. Good? All right, we will now substitute. A was 1, b is a negative 2, and c is a positive 5 from over here. X equals negative 2 plus or minus the square root of negative 2 squared minus 4 times 1 times 5 over 2 times 1. Good? So that becomes negative 2 is just a positive 2 plus or minus the square root of 4, because negative 2 squared is 4. 4 times 1 is 4. 4 times 5 is 20. So it's 4 minus 20, right? Over 2, which becomes 2 plus or minus the square root of negative 16 over 2. Now I want to keep going. I don't want to just say no solution because this is a negative 16 under a radical. So I'm going to factor it like I factored negative 25 became 25 times negative 1. So here I'm going to say negative 16 is negative 1 times 16. I should stop putting it in that order because we have to put the I behind the over 2. Good? So 2 plus or minus the negative 1, the square root of negative 1, just like here, becomes I, right? And what is the square root of 16? The square root of 16 is 4. Good. Now I can take 2 divided by 2 becomes 1, right? Plus or minus 4 divided by 2 becomes 2i. So x is 1 plus 2i, and x is 1 minus 2i. That was just an opportunity to not stop when we saw a negative under the radical. Mosquitoes in here. Last part of Monday's class is the discriminant. The discriminant is just the part of the quadratic formula that is under the radical. So if you want to decide before you start working on the quadratic formula, how many solutions your equation will have, you can solve it for the discriminant first. If your discriminant is 0, then you have one solution, right? Because the square root of 0 is 0. And if it is less than 0, so if you get a negative number under that radical, then you will only have complex numbers as your solutions. All right, so the discriminant is just the part of the quadratic formula the discriminant is just this, right? And so if this number is positive, you'll get two solutions because you're going to take b or negative b and add that, get one of your answers. Take negative b and subtract that, get your other answer. If it's 0, there's just going to be one solution because if you add 0, you get the exact same number as if you subtract 0 from that same b, right? And if you have a negative under here, if your discriminant is less than 0, then you have two solutions, but they're in the complex number universe, okay? So they're not asking you to solve these. They're just saying, how many solutions do we have, okay? Using only the discriminant. So we're going to find A, B, and C, and we're just going to plug them in to only the discriminant. A for the first one is 2, B is -4, C is 1. Good. And our discriminant is B squared minus 4 times A times C. So that's -4 squared minus 4 times 2 times 1. So you're just doing kind of the middle of the quadratic formula to decide how many answers you will get. -4 squared is 16. 4 times 2 is, sorry, -4 times 2 is -8. -8 times a positive 1 is -8, right? So my discriminant is 8. That doesn't mean that that's my answer, but it's greater than 0. So we have two solutions. We don't know what they are because we didn't do the rest of it, but we know how many solutions we should have. Next. Here, A is 1, B is -2, C is 6. The discriminant is B squared minus 4AC. So that's 2, was it -2? Sorry, -2 squared minus 4 times 1 times 6, right? 4 minus 4 times 6 is 24. So that's a -20. That means it was less than 0. So it has two complex solutions or imaginary solutions. Our last one, I'll just put it down here. A is 4, B is 12, C is 9. So our discriminant is 12 squared minus 4 times 4 times 9. 12 squared is 144. 4 times 4 times 9. 144 also. So our discriminant is 0. So that is one solution. And it would not be a complex solution. One real solution. Good. All right. I think I can get all the way through radical equations today. Number 3 on the first page is difficult. Radical equations is exactly what it sounds like. It's an equation, but part of the equation is under a radical. Specifically, the variable is under the radical, okay? So the steps for solving a radical equation are to isolate the radical to one side, like to the left, and then eliminate the radical through inverse operation. Inverse operations: add, subtract, multiply, divide. The square root undoes the square, right? And remember that if it's a square root, it undoes squared. You can also have third roots to undo 3, fourth roots, right? As many as you need. So those are all inverse operations of one another. Then you're going to solve it. And then if you put both of your answers back into your original equation, both of them might not always work. And so if you found that answer correctly, you didn't do any math, any wrong math, but you found that it didn't work back in the original equation, it's just called extraneous. So sometimes you find two answers through good math, but if you don't check them, only for radical equations, if you don't check them, you might have one extra solution. So specifically for radical equations, put them back into your example, put them back into your original equation to make sure that they work, that they're not extraneous. All right, for example 1, this is the third root. You cannot see that at all. We are taking the third root of 1 minus 2x minus 1, and all that is 0. Nope. I don't like how I wrote that or how I said it. So we are only taking the third root of 1 minus 2x. And then that minus 1 is completely separate. Equals 0. Good. All right, so our first step says isolate the radical to one side. This is not isolated because of that -1. So I'm going to add 1 to both sides. I have that same third root of 1 minus 2x. Now it's equal to 1. Good. Okay, so we did the opposite of subtracting 1 when we added 1. Now we need to do the opposite of the third root because everything, including x, is under a third root. What is the opposite of the third root? If I look up there at my list, it's this one. I have this situation, so I need to raise everything to the third power. I had a -1, so I need to add 1 to both sides. I have a third root, so I need to raise both sides to the power of 3. Okay. Thanks for telling me. So when I raise this to a power of 3, all it does to this side is eliminate that. So I can rewrite it as 1 minus 2x. 1 to the third is just 1 times 1 times 1, which is 1. Good. All right, keep going. Subtract 1 from both sides, we get -2x equals 0. Yeah. Divide by -2. X is 0. We have one solution. Again, I said make sure you check it. So if x is 0, is the third root of 1 minus 2 times 0 minus 1 equals 0. So that -1 was not under the radical. I apologize. So this was the third root of 1 minus 2 times 0. We get 1. -1 equals 0. Yes. So that solution is a good solution. Second example is we just have the square root, so we would cancel that with a square. The square root of 12 minus 2x is x minus 2. Good. All right. So we have isolated everything to one side, or sorry, we have isolated the radical to one side of the equation. Now we need to eliminate the radical. So it's a square root. We eliminate it by squaring. So we're going to do that to both sides. This cancels this. All I have is 12 minus 2x on this side. However, on this side, I have x minus 2 quantity squared. So that's like saying x minus 2 times x minus 2. That all right? Okay, now what do we do if we just have a bunch of x's, right? We're still solving for x. Well, let's keep going. In this case, right, if these weren't being multiplied, but I just had a bunch of x's, I would move all the x's to the left, and I would move the constants to the right, right, and solve x equals, like this one, x equals 0, right? However, here I'm going to multiply, and I'm going to end up with an x squared. So if you're multiplying and you end up with an x squared as well as an x in your answer that doesn't factor out, then you set it equal to 0, and we practice factoring, okay? Just wanted to make that clear because it can be mysterious what to do. So I'm going to rewrite this as 12 minus 2x. Nothing's changing over here. But here it was x minus 2 squared. So that means x minus 2 times x minus 2. So I'm going to go ahead and FOIL that out. X times x becomes x squared. X times negative 2 is negative 2x. Here negative 2 times x is another negative 2x. And negative 2 times negative 2 is a positive 4. 12 minus 2x equals x squared minus 4x plus 4. Good. Set everything equal to 0. Okay. So I like my squared being positive, so I'm going to move the 12 and move the 2x. You can do it at once or one step at a time if you want. So now I have 0 over here. Negative 4x plus 2 is negative 2x. 4 minus 12 is a negative 8, right? All right. Now we just practice factoring. Again, you can factor it. You can use perfect squares, which this isn't. You can use the quadratic formula if you want, okay? Does not matter how you solve it, if it is factorable. So x squared would become x times x, right? We can just see if it's factorable. And then to find these two terms, I would need something that multiplies to equal negative 8, adds to equal negative 2, right? Negative 8 could be negative 8 and 1, negative 4 and 2. Ooh, that one works, right? So this would be x minus 4, x plus 2, because when I add them, I get negative 2. When I multiply them, I get negative 8. So we're not done yet. 0 equals the quantity x minus 4 times the quantity x plus 2. All right, we need to solve for x. We're not done. 0 equals x minus 4. I add 4, add 4. X is a positive 4 in this case. Here, 0 equals x plus 2. I'm going to subtract the 2 from both sides. X is negative 2. Let's make sure both of those work. So we got x is 4, and we got x is negative 2. The square root of 12 minus 2 times 4 is 2. 4 minus 2 is 2, so that one's okay. With negative 2, we have 12 minus 2 times negative 2. Or sorry, 12 minus 2 times negative 2 is 4. Negative 2 minus 2 is negative 4. So that is an extraneous solution. You would only want to write the x equals 4. All right, problem 3 is the most difficult thing we will do together today. Like, I don't know. I think it's very hard. I'm not going to say it's like the hardest thing we'll do in this class, but. All right, we have the square root of 2x plus 3. We're subtracting another square root of x minus 1 equals 1. You can't, unfortunately, just square everything with it like this. Instead, we need to isolate one of the radicals at a time. We can't say that we're squaring all of this. Okay, that's too much. So we're going to move one. And then we can square it all. 2x plus 3 is 1 plus x minus 1. The square root of 2x plus 3 is equal to 1 plus the square root of x minus 1. To get rid of this first radical, we're going to square it. That means we have to square all of this at once. Okay, just like we squared everything on this side, we have to square everything on this side. So that means this is eliminated, and we have 2x plus 3 is, right? 1 plus the square root of x minus 1 times 1 plus the square root of x minus 1, because it is that times itself. Just like when it was x minus 2, we're going to square it, or sorry, we're going to FOIL it. Oh. 1 times 1 is 1 squared. Right? Or 1 times 1 is 1. 1 times the square root of x minus 1 is the square root of x minus 1. Now we're on to, so that was the first and the outside. The inside is the square root of x minus 1 times 1. So that's just the square root of x minus 1. And then the last is the square root of x minus 1 times the square root of x minus 1. Good. All right. I'm going to write it again. Everything on this side stays the same. 2x plus 3 equals 1 squared is just 1. Let's look at this. We have the square root of x plus 1, and then we have the positive square root of x plus 1. We can just count those. There are 2 of them now, okay? So we now have 2 square root of x minus 1s. We're just combining those two like terms. Here, look what we can do. This eliminates this, and so we can just say plus x minus 1. That no longer has the exponent. So now we have 2x plus 3 equals 1 plus 2 times x, the square root of x minus 1, plus x minus 1. Don't hesitate to ask me a question. Now I can combine like terms even further. So it is 2x plus 3. The like terms that I see are 1 minus 1. Oh, sorry. Has this been a plus 1 the whole time? I apologize, guys. These are all supposed to be pluses. At least it was an easy fix. I haven't messed anything up. That'd have been bad. All right. 1 plus 1 just becomes 2. Right? Then we have a single x. And then we have 2 times the square root of x plus 1, not minus. Sorry for that mistake, to further complicate the most complicated thing we will learn this entire semester. Good? Okay, now I only have one radical, so that's good, right? I got rid of one of the two radicals. Now I want to isolate this radical so that I can do that same thing one more time, okay? So let's move that 2 just the way, so we want this alone, okay? It's okay to move some x's over here because we still have to isolate this before we can simplify and solve for x. So let's move the 2 by subtracting 2 from both sides. 2x, 3 minus 2 is 1, right? That's gone. X plus 2 times the square root of x plus 1. Now let's move the x. Put it right under that 2x because those are like terms. 2x minus x is x plus 1. Good. Equals 2 times the square root of x minus plus 1. I just really want it to be a minus for some reason. All right. This is not isolated yet. What do we need to do? Get rid of the 2. So we're going to divide by 2 to cancel that. And I'm just going to leave it like that. I'm just going to leave this as x plus 1 over 2 equals the square root of x plus 1. Now that is isolated. So what do I need to do? I need to do the inverse. The inverse of the square root is to square it. And we're going to square this side. Good. If I squared this side, that means I'm taking that entire quantity and multiplying it by itself. Here, it just cancels it. So all I have is x plus 1. Good. All right. Now, you're just multiplying two fractions. Do you remember how to multiply fractions? Straight across, right? So now I just have x plus 1 times x plus 1 over 2 times 2, right? Got rid of all our radicals, yay! We're going to FOIL this. X times x is x squared. X times 1 is x. 1 times x is x. 1 times 1 is 1. 2 times 2 is 4. Good. That could also be written as x squared plus 2x plus 1 over 4 equals x plus 1. Right? I want to get rid of the fraction. I would rather that not be a fraction. So I'm going to multiply both sides by our denominator, which is 4. So multiply that side by 4, multiply this side by 4. On that side, all that does is cancel it. So I can rewrite it as x squared plus 2x plus 1 Here I distribute the 4 equals 4x plus 4. Good. Now we're going to set it equal to 0 because we have x squared and x. So subtract 4x, subtract 4x, x squared minus 2x plus 1 equals 4. So I'm going to subtract that 4. X squared minus 2x minus 3 equals 0. Yeah? All right, we're almost there. X squared minus 2x minus 3 equals 0. Is this factorable? It needs to multiply to equal -3, add to equal -2. Yeah, it could be -3 and 1, right? Those multiply to equal -3, and they add to equal -2. So now I have x minus 3 is 0, x is 3, x plus 1 is 0, x is -1. Good. Again, go back, put them into the original equation to make sure that they are not extraneous. But that's number 3. And I lost some pages. I lost my page 2. Yay, here it is. All right, find the real solutions. Don't worry, we just did the hardest part. Okay, remember the rule for exponents. If I have x to the power of a fraction, m over n, I can rewrite that as x under the radical of n to the power of m. The bottom of the fraction becomes my index, the top of my fraction becomes my exponent. Okay, so that's what I'm going to do immediately. I'm going to change this to a radical equation. My x in this case is the entire thing, 3x minus 5. It's being raised to 1/2. So that means that the 1 is my exponent, and the 2 is my index of my radical, right? So it's being raised to 2. Another way to write this is just 3x minus 5 squared, right? Because if I write nothing here, it's an understood 2 equals 2. Any questions about how I did that? Use this rule. Okay. Now, to undo it, square this side, square this side. By squaring that, I just got rid of the radical. So it's 3x minus 5 equals 2 squared is 4, right? Now we're just solving for x. Add 5, 3x equals 9, divide by 3, x is 3. Here I have 2x plus 1 to the power of 1/3. If I look up at this, right, my base is 2x plus 1. That top number is my power. That bottom number, that denominator, is my index. So it's the cube root of 2x plus 1 equals, -1. Good? All right, so get rid of that cubed root. I raise it to a 3rd power. Raise -1 to the 3rd power as well, so that gets rid of that. It's just 2x plus 1, because that gets rid of that. -1 3 times. -1 times a -1 becomes a +1. +1 times -1 becomes a -1. So 2x plus 1 equals -1. -1 to the third power is a -1. Subtract 1 to solve for x. 2x is -2. Divide by 2. X is -1. A little bit better. Oh my gosh, we can do it. We can do it. All right, solve the equations by factoring. Remember, factoring is often something like this, right? It's not always, though. Here we have x to the fourth equals 9x squared. But if you are going to factor, the thing you do need is you need to set it equal to 0, which is standard form. So this is x to the fourth. I'm going to subtract 9x squared so that it is in standard form. So if I subtract everything that's on the right from both sides, I get 0 on the right and I get it in standard form on the left. Standard form as long as you're going from the biggest exponent down to the smallest. Good? Now, how can I factor x to the fourth minus 9x squared? Not like this, right? But I can find a common denominator. I can divide both of these by x squared, right? So my factors are x squared and whatever answer I get when I divide x to the fourth by x squared, I get x squared. When I divide -9x squared by -9, I get -9. Is that okay? So my two factors are x squared equals 0 and x squared minus 9 equals 0. Just like over here, right? So here we factored it into two binomials. Here we have a monomial and a binomial. But again, as soon as you have two factors set equal to 0, you just solve each of them for x. Okay? It's okay that one is a binomial, sorry, and one is a monomial. X squared equals 0. Take the square root of x squared. The square root of 0 is 0. So you don't need +0 and -0. They're both 0. Good. So x equals 0 for that first one. X squared minus 9 equals 0. So I'll add 9 to both sides to solve for x. X squared equals 9. Good. Now same thing. I never leave it up for the plus and the minus. Good. X squared becomes x. We have plus or minus. So the square root of 9 is 3, right? So we have x equals -3 and 3. And I'm so sorry. We also have this one over here. I forgot about him. So these are all of our answers. So we have x is -3, 0, and +3. The two answers for this were -3 and +3. The one answer for this was 0. So all three of our answers together are 0, -3, and +3. Last one today is x cubed plus 4x squared minus x minus 4. And remember, that is the rule. If a times b equals 0, then a equals 0 or b equals 0. So we're just trying to factor it so that we can set it equal to 0 and solve for our x's. Again, here, this doesn't easily go into two binomials because it's not a single polynomial with just x squared plus x plus a constant. Instead, what we can do is we can factor by grouping. So we have x cubed plus 4x squared. I can factor out an x squared, right? So that becomes x squared times x plus 4. Negative x minus 4, so I can only factor out a negative 1 because you have to use whatever sign is between the two. Negative x divided by negative 1 is a positive x. Negative 4 times divided by negative 1 is a positive 4. Good. Now, our common factor is x plus 4, and that was being multiplied by x squared and negative 1. Good. Now we just solve each of these like we did here. X plus 4 is 0. X is negative 4. And then over here we have x squared minus 1 is 0. X squared equals 1. Take the square root of x squared equals the positive and negative square root of 1. X equals negative 1, 1, and negative 4. Good. All right, 2 minutes left. I will stop our recording.